Alright, so the first spectrum we have here is unknown number 2. It's L2. First of all, I'm going to kind of do this where I discuss each individual spectrum, so all 3 of them, and then at the end I'm going to go back and kind of conclude what each of them. I'll conclude what they are. I think they are as I go along, and then at the end I'll incorporate all of them together. For this one right here, for this spectrum here, we see sp2 CH bond right here at approximately 3078. This one right here, it more than likely will be sp3 CH bond. This one right here is actually, we can disregard this peak right here. It's actually CO2. This one over here is, since it's around 1650, I would say it's more than likely a CC double bond. Then of course we have our fingerprint region. The results that we got for L2, of course, here's a chart of our major peaks that we got. Of course we can disregard the CO2, but I made a chart here to kind of demonstrate why I don't think the other ones are it. In 2-pentanol, the OH group is not present. In cyclohexanone, the carbonyl group is not present in the spectrum. Of course, we don't see any NHs. There's no aromatic ring present. No OH again. The carbonyl, aromatic. They're just not present. So that leads me to believe that this alkene up here it gets me to lean toward 1-octene, especially since it shows an sp2 hybridized CH bond around 3078. So for L2 we got 1-octene. That's our conclusion. Here's our spectrum for unknown L4. For unknown L4, we can see the sp3CH again around 2052. That seemed pretty evident. That was definitely a major peak. Of course, we can disregard our CO2 absorbance again. Around here, this one was sort of difficult to see, but by looking at the other molecules and their forms and their functional groups, this peak right here sort of leads me to believe that it could be an NH, and I even went further into the fingerprint region, even though it's not a major peak, and I kind of diagnosed this peak right here around 1090 to be a CN bond of an amine, and then this one right here is a NH. Those 2 peaks right there are NH bonds. That's what I came to conclude. And for L4 here, of course the frequencies here, we have our sp3CH, our disregarded CO2, and then possible NH or CN bond. Of course, I have to look at the other molecules to see if any of them could be it. Of course, there's no alcohol group or carbonyl group, in there. There's no aromatic ring, no alcohol. We don't see any sp2 hybridized CHs. Of course, and there's the carbonyl and aromatic. Those are not present again. And I narrowed it down to 2 on this one. It's either the cyclohexylamine or the bromobenzene. And the cyclohexylamine, since I thought that those others could be NH bonds, I think that the spectrum would match up better with a cyclohexylamine. That's why I sort of looked at the fingerprint region to try to deduce what it could be. The bromobenzene, of course, it should have an aromatic ring, and I don't really think an aromatic ring is present in this one. So, my conclusion would be that it's cyclohexylamine. Lastly, our last spectrum was for S5. That's our solvent analyzed using the ATR-IR spec. There's definitely an alcohol group present around 3648. Right here, there's the sp3CH that we could deduce. Of course, we're going to disregard our CO2 again. And right around 1500 here, it looks like we could have an aromatic ring. So, of course, I think all the molecules do have an aromatic ring, so that should be present. For our results, of course, there's our chart with the alcohol, the sp3CH, the disregarded CO2, and the possible aromatic ring. The first one I ruled out because there's really no true, carbonyl, carboxylic acid group there displayed. And also this contains the NH bond, and that's just not present in this spectrum. The vanillin is actually what we thought it was, but we narrowed it down to vanillin and mandelic acid. Of course, the last three are out because there is no alcohol bond, and again, there's no ester slash carbonyl group in there. We ruled out mandelic acid because, well, that true carboxylic acid is not present that we would expect to see that sharp peak. So we lean more towards vanillin. The aromatic ring with the sp3 hybridized CH was a big key factor in picking that, and of course, the alcohol in there. So our conclusion for S5 would most likely be vanillin. And here's all our results and conclusions. Of course, after evaluating all three spectrums, major peaks caused by functional groups, of course, were determined for each. The peaks give us clues as to what possibly could be the functional groups. A presence or lack of those specific functional groups can help us determine which could belong to each spectrum. Of course, L2 we got 1-octene, L4 cyclohexylamine, and S5 was vanillin. Before I get to the references, I wanted to put some possible errors that could have happened within our experiment. I think when we did the solid hour, the hour spec on the solid with the ATR attachment, you have to make sure when you use the knob that you don't tighten it too much and it's not too loose. You want it tight enough but not too tight. And I think when we ran it the first time, it was a little bit too loose, and the spectrum was just haywire. So we ran it again. It was a little tighter. It was better, but I still think it possibly could have been better, even though we ran an extra 48 scans on it. So if I were to do this experiment again, I would definitely put more. I would monitor that attachment more and make sure that I could get it, as perfect as I could get it. Another mistake, I think it's just precautionary, is we could run more scans on each, product or sample that we evaluated, just simply to get more defined peaks that were easier to possibly read. And I don't think this actually occurred to us, but you always want to make sure you place your product directly in the middle of the salt plate to ensure the best read from the spectrometer. Of course, like I said, I don't think that happened to us, but that's definitely an error that you want to make sure doesn't occur. Like I said, if this experiment were to be done again, I would definitely use more scans and monitor that ATR attachment on the IR spec for our solids. Small details like that can make a huge difference in your outcome. As far as our references go here, the first two here are about pictures cited from the first side of the IR specs. They're laboratory equipment websites. 3 here is actually our organic textbook that, I thought some good examples from that would be, helpful in this presentation for, IR spec and mass spec. So there's definitely some useful stuff from that. 4 here, it was another picture from, this is Department of Chemistry of Colorado, definitely useful. 5 here was from Sigma Aldrich. You were able to get the absorption frequencies there. As far as the chart showed on like slide 3, those absorption frequencies came from there. Reference 6 here, of course, was from Padillas, our laboratory, book. That cites information talked about briefly that I discussed regarding IR spec and mass spec, and I just wanted to go ahead and reference that since I did cite some of the stuff from that. But this is it for